So, hi everyone. I am M. Purnima Devi from SNS College of Technology, Department of Artificial Intelligence and Machine Learning. So, now I am going to discuss about full stack AI, topic by applications of AI. So, in application of AI, there are many more applications in AI. So, now I am going to discuss about language models. So, language can be defined as a set of strings. Print, for example, print 2 plus 2 is a legal program in the language Python where 2 plus 2 print is not exist. So, since there are an infinite number of legal programs, they cannot be enumerated. Instead, they are specified by a set of rules called a grammar. Formal languages also have rules that define the meaning semantics of a program. For example, the rules say that the meaning of 2 plus 2 is 4 and the meaning of 1 cross 1 divided by 0 is that an error is signated. Natural languages such as English or Spanish cannot be categorized as a definite set of sentences. Example, everyone agrees that not to be invited is said in is a sentence of English, but people disagree on the grammatically of to be not invited is said. Therefore, it is more fruitful to define a natural language model as a probability distribution over sentences rather than a definitive set. N-gram character models. An n-gram model is defined as a Markov chain of order n cross 1. In Markov chain, the probability of character Ci depends only on a immediately preceding characters, not on any other characters. So, in a trigram model, Markov chain of order 2, we have P bracket C4 slash of C1 is to 1 minus 1 equal to P C of 4 slash of C4 minus 2 is to 1 minus 1. We can define the probability of a sequence of characters P C1 is to n under the trigram model by first factorizing with the chain rule and then using the Markov assumption. So here P C of 1 n equal to 0 O. So P C of 1 C1 is to 1 minus 1 equal to O 1 is to 1. From that I initiate 1 to infinite numbers. So P C of I slash Ci minus 2 is to 1 minus 1. So this is the from that the language models can be we can calculated smoothing n-gram models. The major complication of n-gram model is that the training corpus provides only an estimate of the true probability distribution for common character sequence such as the any English corpus will give you a good estimate about 1.5% of all trigrams. On the other hand, HT is very uncommon. No dictionary words start with high T. It is like that the sequence definitely would have a count of 0 in a training corpus of standard English. Does that mean we should assign p th equal to 0? If we did, then the text in the program issues us an HTTP request would have an English probability of 0, which seems wrong. The process adjusting the probability of low frequency counts is called smoothing model evaluation. The evaluation can be a task specified metric such as meaning, accuracy, or language identification. Alternatively, we can have a task independent model of language quality. Calculate the probability assigned to the validation corpus by the model. The higher the probability, the better. This metric is inconvenient because the probability of a large corpus will be a very small number and floating point underflow becomes an issue. A different way of describing the probability of a sequence is with the measure called perplexity. Defined as perplexity, C is 1 is to n equal to P, C1 is to n. So to the power of minus 1 slash n. N-gram world model. N-gram models over words than rather than characters. All the same mechanism applies equally to word and character models. Main difference is that the vocabulary, the set of symbols that make up the corpus and the model is large. There are only about 100 characters in most languages, and sometimes we build character models that are even more restrictive. For example, by treating a and a is the same symbol, or by treating and punctuation as the same symbol. But with word model we have at least tens of thousands of symbols, and sometimes millions. The wide range is because it is not clear that constitutes a word. World n-gram models need to deal with out of vocabulary words. In these conditions, information retrieval, IR source, scoring functions, IR system evaluation, IR refinements, pan-crank algorithm, the HITS algorithm, image extraction, finite state automate for information extraction, machine translation systems. All translation systems must model the source and the target languages, but systems vary in the type of models they use. Some systems attempt to analyze the sourced language text all the way into interlingual knowledge base representation, and then generate sentences in a target language from that representation. This is difficult because it involves three unsolved problems: creating a complete knowledge representation of everything, passing into that representation, generating sentences from that representation. Other systems are based on a transfer model, statistical machine translation, find parallel exits, segment into sentences, align phrases, extract distortions, improve estimates with EM. Speech recognition is a definition. So speech recognition is a task of identifying a speech sequence of speech words underrated by a speaker given the acoustic signal. It has become one of the mainstream applications of a robot. Robots are physical agent, robot hardware, robotic perception. So planning to move, configuration space, cell decomposition methods, modified cost functions, skeletalization methods. So this is an replying potential field pushes the robot away from obstacles path found by time, simultaneously minimizing path length and potential. Explain about automatic speech recognition. So speech recognition is an interdisciplinary field of computer science and computational linguistics developed methodologies and technologies that enable the recognition and translation of spoken language into text by computers. It is also known as automatic speech recognition, computed speech recognition, or speech to text editing system architecture of for automatic speech recognition system. In this architecture, our speech signal is given into pre-processing and future extraction. So from that signal goes into a if parametric features, it goes into a pattern classification. The testing process is taken, and the training model generation. So speech a database which given into the acoustic model. So all the data are collected into the databases. So from a text corpus, so language models, all the models are given into the language, all the text corpus is given into the language models. From that the model generation, from that pre-processing future extraction goes into a pattern classification. So from that all the patterns are classified, and the speech is taken out and converted into speech and transcription. So thank you everyone.